Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm your host, Victor, and with me as always is my brilliant co-host, Sheila. Today, we're diving into Chapter 4 of our journey through operating systems, and we'll be exploring the fascinating world of threads.
That's right, Victor. We're starting a new chapter, and it's all about threads. This is a crucial concept in modern operating systems, and I'm excited to break it down for our listeners. Let's start with the basics. What exactly is a thread?
Great question, Sheila. A thread, in the context of operating systems, is the smallest unit of execution within a process. You can think of it as a lightweight process. While a process is an independent program with its own memory space, threads are components of a process that share the same memory space but can execute independently.
That's a great explanation, Victor. To help our listeners visualize this, imagine a process as a kitchen and threads as chefs working in that kitchen. They all share the same resources, like utensils and ingredients, but each chef can work on different dishes simultaneously. The chefs can communicate easily and work efficiently together, just like threads in a process.
I love that analogy, Sheila. It really helps to illustrate the concept. Now let's talk about why threads are so important. In modern computing, multi-threading has become a crucial feature. Can you elaborate on the benefits of using threads?
Absolutely, Victor. There are several key advantages to using threads. 1. Improved responsiveness. In a multi-threaded application, if one thread is blocked, other threads can continue executing. 2. Resource sharing. Threads within the same process share resources, which is more efficient than having separate processes. 3. Economy. Creating and managing threads is less resource-intensive than creating and managing processes. 4. Scalability. On multiprocessor systems, threads can run in parallel on different processors, significantly improving performance.
Those are excellent points, Sheila. It's worth noting that many applications we use daily, like web browsers and word processors, use multi-threading to provide a smooth user experience. For instance, in a web browser, one thread might handle user interface updates, while another loads web content in the background.
Exactly, Victor. Now let's delve a bit deeper into the types of threads. Generally, we can categorize threads into two main types: user-level threads and kernel-level threads. Can you explain the difference between these?
Certainly, Sheila. User-level threads are managed by a thread library at the user level without kernel support. They're fast to create and manage, but can't take advantage of multiple processors. Kernel-level threads, on the other hand, are supported and managed directly by the operating system. They're slower to create and manage, but can run in parallel on multiprocessor systems. Many modern operating systems use a combination of both, known as hybrid threading models.
That's a great explanation, Victor. It's important for our listeners to understand these distinctions, especially if they're preparing for technical interviews. Now that we've covered the types of threads, let's move on to some basic thread operations. What are the fundamental actions we can perform with threads?
Great question, Sheila. The basic thread operations include 1. Thread creation, starting a new thread within a process. 2. Thread termination, ending a thread's execution. 3. Thread joining, waiting for a specific thread to complete before continuing. 4. Thread yielding, voluntarily giving up the CPU to allow other threads to run. 5. Thread synchronization, coordinating the execution of multiple threads to avoid conflicts.
Excellent summary, Victor. These operations form the foundation of thread management in operating systems. It's crucial for developers to understand these concepts to write efficient, multi-threaded applications. For our listeners preparing for interviews, being able to explain these operations and their use cases can be very helpful.
Absolutely, Sheila. And it's worth mentioning that while threads offer many benefits, they also introduce complexity. Developers need to be careful about issues like race conditions and deadlocks when working with multiple threads. But we'll dive deeper into those challenges in future episodes.
That's a great point, Victor. As we wrap up this overview, let's recap the key points we've covered today. 1. Threads are the smallest units of execution within a process. 2. Multi-threading offers benefits like improved responsiveness, resource sharing and scalability. 3. There are user-level and kernel-level threads, each with their own advantages. 4. Basic thread operations include creation, termination, joining, yielding, and synchronization. 5. While powerful, threads also introduce complexities that developers need to manage carefully.
Excellent summary, Sheila. This overview sets the stage for our deeper exploration of threads in the coming episodes. We'll be diving into multi-core programming, threading models, and much more. Thank you, listeners, for tuning in to this episode of Operating Systems Crashcast. Remember, understanding threads is crucial for modern software development, so keep these concepts in mind as you continue your journey in operating systems.
Absolutely, Victor. And as always, we encourage our listeners to experiment with these concepts in their own projects. Try writing some multi-threaded programs to see these principles in action. Until next time, happy coding!